you for coming to the first meetup of this year. So we have Brady, who's from Capital One. He's been working in Capital One for quite a long time actually. So he's going to talk about like Lambda applications and debugging them with the local Spark Debugger. It's a very niche topic and a very interesting topic. Before we get started, I just want to give you a couple of updates. So this meetup is, like you can see, is being hosted by Collabera, to whom we are very thankful. For the next meetup, we are going to be hosting this at Improving in Plano. And the next meetup's topic, we're still finalizing that. From now on, the meetup will be held first Wednesday of every month. So, a fixed date from now on. And we are looking for speakers to speak at the meetup. So if you're interested in presenting a topic, just reach out to us, message us on the group, or you can reach out to either Iqbal or me, and we'll be happy to guide you through like what we're looking for from the topics and like, what we're expecting. Anything else that I should? Another thing, Capital One's hiring. So if any of you are looking for jobs, if you're interested for exciting careers in data, Capital One's hiring. So we are looking for full-time positions as well as contractors. So if you want to reach out, we do a lot of our recruiting through Collabera. So you can either reach out to Capital One or you can reach out to Collabera. We can work something out. With that, I'll let Brady take it over. Thank you so much.
Hello everybody, welcome to the meetup today. My name is Brady Jiang. I'm a data engineer with the Capital One analytical group for 5 years. Working for the Capital One auto finance decisioning the deal group. Today I'm going to talk about introduce a tool called Spark Local Debugger that helps developers to debug and troubleshoot issues with Spark application. So before I start, let me ask the audience, how many of you have developed a Spark application before? Two. You? 3. So pretty majority of the audience are pretty new to the Spark, and so that's fine. I will give a overview of the Spark concept later on. For the three of you who have built Spark application. What scale of the application you built and what methodology you use to debug? What's the size of the data you deal with?
The largest file was 1 gig.
Okay.
Yeah. The data set was around 500 gigs.
500 gig. Did you use any methodology to troubleshoot problems?
Right now, we aren't using any separate tool. That's precisely what I'm interested in.
Okay, cool.
So, right now, the tools that we have used, we haven't used specific coding tool. We have teams which help us with the debugging and testing. But as a data engineer and as a developer, yes, that's what I'm interested in.
Okay. And you?
Yeah, so probably the volume is around like 40 million rows on each load.
40 million rows?
40 million rows on each data load.
Okay.
Refresh rate of 5 minutes. So yeah, it's large. But for debugging, there's no really good solution that we found so far. Like it's a lot of manual validations and yeah.
Log files.
Yeah.
Okay. So that's thank you for answering. And yeah, that's exactly the problem that we are trying to solve today by introducing this tool. And so before, so here is the agenda of today's talk. First, I will cover the background concepts. I will just cover the important concepts of Spark, Debugger, IDE, and then I will do a code review of a sample Spark application. And then I'll talk about why this tool was created and what this tool is. And then I'll do another code review of this library and do a demo run of this sample Spark application using this library. And then lastly, I will close up with the next steps and the Q&A. So some highlights of the Spark architecture. It's an open source distributed parallel, a general purpose cluster computing framework developed by originally by UC Berkeley in 2009, and then spun out as a commercial company called Databricks in 2012. And it's built around the data architecture called Resilient Distributed Dataset, RDD. Although they have introduced a new format of the data called data frames and data sets, but they are all based on RDD concepts. So RDD concept is still being used and not deprecated. And then because the data are distributed across a cluster of nodes in memory in the format of RDD, so the Spark requires some kind of a manager, cluster manager, to manage this the data distributed on these nodes. So there are multiple kinds of cluster manager. Standalone Spark, there are native Spark manager, Apache Yarn, and Kernels. And also Spark supports a pseudo distributed local mode that basically is used for development and testing purposes, where distributed storage is not required, and the local file system can be used instead. And that is the foundation of developers to use some kind of debugger to attach to the Spark application to debug the application locally. And then the Spark. So this slide covers some basic concepts of the Spark, and these concepts will be used later in my talk to demo the tool. So a little bit mundane, but they will be used later. And then Spark Core is the foundation of the Spark project. It provides a distributed task dispatching, scheduling, and basic I/O functionalities, and it's exposed through an API available in 4 languages: Python, R, Java, and Scala. You can view the Spark Core as a core written in Scala, but available using 4 languages. It's like 4 kinds of doors that can access the same core of So the Spark core basically, this is an interface that mirrors a functional higher order of model of programming, which include a driver program that invokes the parallel operations such as map, reduce on RDD by passing a function to Spark, which then schedules the function's execution in parallel on the cluster. So Spark core schedules a Spark job, and the Spark job is usually a chain of RDDs. You first ingest data into a RDD, and then because RDD is read-only, you have to do transformation on it to create a new RDD, and then a new RDD. It's a chain of RDD, and then it produces the output, and the output can be saved anywhere. So that's usually what the Spark core does. And that leads us to the RDD manipulation functions. There are two types of them. So these functions basically are the functions that take a RDD, does some RDD manipulation. There are two kinds of them. One is the transformation function. The other is the operation function. What transformation function does is basically takes RDD as an input and then do some transformation on it and then produce another RDD. Transformation, which means that this diagram indicates that the change that applied onto the data of RDD are happening within the same cell of that RDD. It doesn't go across cells, and that includes these functions: map, flat map, filter, etc. And then there are wide transformation. So these are more complex transformation functions that involves the entire population to shuffle around, basically. And there are these this list of functions that does the wide transformation. In fact, these are the entry point provided by the Spark core for developers to pass another function to complete the transformation. So the RDD, when you want to do a RDD transformation, you need to basically, it needs two parts. One is these entry points, which are provided by the Spark core. But the other part is provided by you, which is part of the title of this meetup, which is Lambda function. So you write a Lambda function and then pass that to these transformation functions, and then Spark core will take your Lambda function and apply that onto each of these records and to complete the transformation. And that's, any questions? So that's about the concepts of Spark, and then another piece that's required for this tool to operate is the debugger, integrated development environment. So nowadays you get free IDE tools like PyCharm available, and Visual Studio Code. All these tools are perfect, are great tools for developers to develop Python applications. or in other languages. So for this talk, I will mainly use PyCharm, which comes with a debugging capability and very convenient to use. So, so I know I have talked a lot about theory, so me personally, I feel like to combine the theory with practical examples. To me, I feel that's very effective way to get a better understanding. So let me just give you some code review of a very simple Spark application. Oh, by the way, the code I'm sharing today are inner sourced within Capital One, has not been open sourced yet. I'm trying to make it open sourced to public, but right now it's not open yet. You guys can, but I think the purpose of today's talk is to give you some idea of how this tool can work, and in the future, this tool may be open source. So that actually is that the part of this tool is a simple Spark application, which is called PySpark demo app. As I mentioned previously, this Spark core framework mirrors a model of programming that requires a driver program. So this is the driver. So
can you make it larger?
Yeah, sure.
Yeah, go to zoom and also increase function. Yeah, right.
Yeah. So so on a high level, this application, what this application does is quite simple. It takes this 10 lines of data, about 4 or 5 columns, to that basically means 10 or 10 loans with some simple attributes as input, and then calculate their monthly payments and total interest. So so that's what this application does. Simple. So the driver is here, and this is a PySpark application, so it's in Python.
Perfect.
Better. Okay. Thank you. So the driver application basically pick up a Spark configuration, and then create a Spark context, and then it create a Spark session, build a Spark session, and then it invokes an engine object. So all the RDD ingestion and manipulations happens with the engine object.
Can you increase the font size?
So engine holds the connection to Spark.
Actually, the driver holds the connection. Driver. So let me just.
So how does the engine relate to Spark? Is it like does the engine represent the server, the cluster?
So engine is just a collection of functions that manipulate RDD.
Okay.
You can do this in driver program too. It's just a neat way to define the RDD manipulation functions. So the data flow on the upper right side is the architecture of Spark, PySpark. So I will talk about that later, but so the driver.
Hey, we're not able to see your code.
You can.
We're not able to see the code.
Oh, okay.
You need to escape the PowerPoint. Exit out of the PowerPoint.
Yes.
Yep.
Yep. Okay. So we create a driver. We create an engine object, which is a collection of RDD transformation functions, and then kick off the engine to an engine run, called engine run function, and so let's look at engine run. So engine run function is the main chain of RDDs, basically. First, it ingests data. So it basically reads the CSV I just showed you into a RDD. It's read into a data frame, long data frame. But data frame is built on top of RDD, so you can view it as RDD. And then it does the repartition, which is a one type of transformation, and then it calls payment function as a Lambda function to derive this payment RDD. And then after doing some operations on the payment RDD, it's calling the calculate interest function as another Lambda function to calculate interest RDD. And then it uses a simple map function to derive to another function. And lastly, that's the result of this Spark application, which has the interest of each loan. So this is a the most simple form of a Spark application that just show you the idea of how Spark application does.
What is this utils debugger on line 70? Is this our package or is it part of PySpark?
This is our package. This
Okay.
is not PySpark. This is the package I will introduce you today. So, so this is a you know, the high-level Spark application workflow look like. Now, why we created this package? So, so even though Spark is a widely adopted and very popular analytical platform used by many large companies, still the lack of a effective debugging tool is one of its weaknesses. And there's a reason for it. Because I view it, the most obvious reason is that the Spark applications run on a cluster of nodes, and it's not a single machine, and so it's almost impossible for you to attach debugger to all these cluster of nodes to see what's going on with each of them. And well, but you can say that the Spark core does provide a local mode to enable developers to attach a debugger to it. It's a pseudo distributed mode of running Spark. Then why you know, that is not leveraged by developers to debug a Spark application? And the reason is that I view it is because from the view of the Spark architecture, the part of the Spark code, a part of the Spark application code is not accessible, even you run it locally. So the diagram on the upper right is the diagram of PySpark architecture, and the part on the left happens on the master node, and then the part on the right happens on the worker nodes, and the white blocks are in Python, and the green blocks are written in Java. And these different languages blocks talk to each other using sockets. The part on the left can be accessed by a debugger, which is this something like this. But the code that executes on the right is a black box and cannot be accessed by a debugger. Even the code, even if you use local mode to run the Spark application. So I think that's the main reason why developers choose to not use debugger to debug Spark application. And then what do they use? So the answer is log files. You know, log file are produced on master node and on worker nodes, but obviously it's a very primitive way to look for errors and to troubleshoot problems. Also, Also, the problem with log file is that the error usually are misleading in terms of pointing down the root cause of the issue. So,
so how is this different if you use a different language, like Scala or Java, they're more coupled to lower APIs. So does it change anything?
no. Even if you use Scala or Java, so the part on the right box not accessible by debugger. The only if you use the log file to look for problems, to try to replicate problems on the worker nodes, you have to access the log file on the worker nodes, which are very hard to achieve. And so log file is the most commonly used way to debug a Spark application, both both on the master node and the worker node. Obviously, it's primitive. Attaching a local debugger to the master node is a second way to debug Spark application. But as I mentioned, it's only limited to the code that runs on the master node. There's a big gap of the code that runs on the client nodes, not accessible by this local debugger. That's the problem that this package tries to solve. So the problem, so the way that this package solves this problem is by doing some manipulation of the RDD transformation functions to move the RDDs that previously sits on the node of the cluster into the master node, and then apply the Lambda function onto these each element of the RDD. And then after that is done in a loop, and then it will be, the result will be distributed to each of the cluster nodes. That's the idea.
So, but the main purpose of RDD is like reducing the effort on the master node and working with the client nodes, right? Mm-hmm. Again, we are moving the same code onto the master node and creating a hefty job onto the master, which is like the main purpose of RDD is missing out when we move the whole code to the master node.
Yeah.
So.
But for development environment, right?
Yeah,
just for debugging.
But say suppose we are just talking about 10 lines of code, say in our application we are using 2 billion records. So in that case, when we are having moving the whole code to the master node and working there for debugging and then bringing back the whole RDDs onto the local is like it may give runtime error or out of memory error or something like that. So
definitely. So I understand that. And debugger is not intended to run on the real production environment. Debugger is supposed to replicate the problems that you encounter on the production environment by sampling the input data
On small scale.
on small scales.
okay.
There's no way to to replicate the 2 billion rows of
Yeah,
input
exactly.
on your local
Yeah,
laptop. And so the purpose of the debugger is to fill the gap of the debugger cannot be attached to the code that runs on the worker node. The way to solve it is to move those code from worker nodes to the master node, and to run your Lambda function on master node, and then move it back to the client on your local computer using the sample data. So, I have given you the idea of this tool, and now this is Spark RDD transformation functions. I will give you a overview of this code review of this wrapper function. So, and then there's code library to automatically switch between local and remote environment, and then so that you can use the same code base to debug locally as well as run it in production environments remotely. And also include a simple Spark application I just showed you. Along with this tool, I also provide a package called Common Data Tools. It's a Python library of Spark I/O functions. So the Spark Local Debugger calls the I/O functions of this Common Data Tools package to ingest data to RDD and then write data to storage. Here's the setup of the tool. I will skip. So I will do a code review of this package, which is quite simple. So this package includes just two modules, Python modules. One is const, which defines a flag of local mode flag. If it's Windows or Mac, it's true, otherwise it's false. So you will use this flag to feed into the wrapper functions, and then the wrapper function will use this flag to tell which RDD transformation function to call. If it's a local mode, then it will do that trick I just told you, which moved the code from the worker nodes to the master node to transform, and then move back to worker nodes. That's the debug mode. If it's a remote, if this flag is false, then that wrapper will call the Spark native RDD transformation function. So here is the wrappers. Here are the wrappers.
Could you increase the font size, please?
Yeah.
Thank you.
So there are multiple RDD transformation functions, but for this use case, I'm just providing two wrappers, map and map value. So you can see that for map, if this is in debug mode, then it will call a collect. This actually is moving the data from the worker nodes to the master nodes. And then it will apply the Lambda function to each of the records in a loop. all these happen on the master node. So your debugger can access the Lambda function. And after it's finished, it will call the parallel lines to distribute back to the worker node. If it's not debug, then it will directly call the RDD map function using the Lambda function as the input. And both ways will return the output RDD. So that's the idea. So lastly, let me do a demo of this tool in action. First, I will run this loan interest calculating application. So in order to use this tool, I need to install Spark locally, PySpark locally. That's it, and the Python. So first, I ingested the 11 loans and display the attributes there, and then calculate. So that this is the payment output of each loan, and these are the interest output of each loan. So these two outputs are calculated using the RDD transformation functions defined in this module. One is the calc monthly payment, the other is calculate interest. So this package, what this package provides is the capability for you to stop here in these Lambda functions. Previously, without this package, you are not able to do it using the Spark native RDD transformation functions. So let me start doing a debug by starting a debug session of PyCharm. I set breakpoints in this here to ingest data. Pass it. And another breakpoint at before the calculating monthly payment. So I set a breakpoint here in the calculate monthly payment. So you can see I'm using the Spark